guys, and happy Thursday. We are going to continue on in section 9.1, integration by substitution today, but now we're going to part 2. And the difference is going to be part 2 is going to start including some of our trig functions. In the last chapter, chapter 8, we learned how to find the derivative and the antiderivative of our trig functions. So they're going to take that knowledge from chapter 8 and combine it with our new integration formula, integration by substitution. If you look inside of your packet, I did include a cheat sheet. This is for your mid-chapter test that's coming up. However, as we're moving through 9.1 and 9.2, once they add the trig functions, this is kind of helpful just to have it set by you so you can remember what is the derivative of the sine or the cosine or the tangent. And again, looking at what is the antiderivative of a cosine, a sine, and a secant squared. So this should be in your packet. It is kind of just a nice tool to have as we start working through integration by substitution today. We are going to go ahead and it's the same process. So I like to rewrite everything where I can kind of figure out what is f of x, what is g of x. To me, it's a lot easier if f of x comes right away. So here, when you're looking at trig functions, your trig function is going to end up being your f of x. In a problem like this, what is the basics? Well, cosine of x. But g of x would be x squared because it's not just the cosine of x. Then I could say, well, I multiplied by 2x dx, and that works because g of x would be x squared, and the derivative of x squared is 2x. So I went ahead and I took this problem, and for me it was much easier if I rewrote it in this format. Again, this is worth 5 points per problem. F of x, your outside function, we're looking at the cosine of x. G of x, well, instead of just an x, we have x squared. The derivative of gx we need to be able to find within our integral. That is a 2x, it matches, so I do not have to put a value out front. Now to find the antiderivative of f of x, which is the cosine. So if I look at the antiderivative of a cosine of x, it is the sine of x plus c. Now it's the same thing. You take the antiderivative of f of x, substitute in g of x, and don't forget your plus c. So this is the sine of, instead of x, it's x squared plus c. And if you wrote that without the parentheses, you are good to go. I naturally just want to put parentheses as I substitute in g of x. Either of these options is great. Okay. Now here's the first trick question. I gave us a couple trick questions today right off the bat. If I am looking for an antiderivative of a tangent, I can't find one. We don't have one. So what I need to remember is that tangent is really the same as the sine over the cosine. So if you have something where we do not know the antiderivative of that, you will need to use your knowledge of trig ratios and rewrite it. So the tangent of x equals sine of x over cosine of x. If you are looking at something in this format, and here's just another trick. I am looking at a fraction. My f of x is 1 over x. And just kind of watch this problem and you'll see how it kind of all comes together. So 1 over x is f of x. Now g of x, well, instead of having just an x on the bottom, we have a cosine of x on the bottom. The derivative of a cosine. The derivative of a cosine is a negative sign. I have a sign here. Okay, it's a sign, it's on the top, it's positive. I need it to be negative. That means I need a negative out front. The derivative of a cosine is a negative sign. Now the antiderivative of 1 over x, that's the natural log of x. So again, I turn the tangent into sine over cosine. This was a fraction. So my f of x could be 1 over x. Instead of x on the bottom, it's a cosine. The derivative of a cosine is a negative sign. My sign was positive. It needed to be negative, so I have to realize that there was a negative out front. That's how the negative is gone in the final answer. The antiderivative of 1 over x is the natural log of x plus c. So there's a negative up front to make the signs match. Natural log of instead of x, it's the cosine of x plus c. So just to make this look a little bit nicer, a negative natural log of the cosine of x plus c. Now that's a challenge question for the day. I put in a couple that I thought were kind of tricky, and I figured let's go ahead right away with number 2 and get a challenge in there. Number 3. Again, I rewrote this. I wanted my trig function, the secant squared of x squared first, times x dx. Because looking at this, f of x, I do know what the antiderivative of a secant squared is, so this can be f of x. Secant squared of x, but I'm not taking the secant squared of just x, I'm taking the secant squared of x squared. The derivative of x squared is 2x. I have the x. Now really this needs to be a 2x. So what happened, if this was really a 2x, is there must have been a 1/2 out front, because 1/2 of the 2 is how it became the x. So I do need a 1/2 out front. Now I keep going. The antiderivative of f of x. The antiderivative of a secant squared of x is a tangent of x plus c. So tangent of x plus c, I do have the 1/2 out front. Antiderivative is the tangent. Instead of x, you fill in your g of x, which is x squared plus c. So just to write it a little bit nicer, I get rid of the brackets. It's 1/2 times the tangent of x squared plus c, and you are done. We're going to go ahead and look at 3 more examples, and that is it for the day. Okay, let's just keep going. Again, 9 times out of 10, if you see e in a problem, that's going to be your f of x. Okay, so that's what I'm going to try first, is I'm going to rewrite this where I want e to the cosine of 2x to come first. Then I would have the sine of 2x dx following. So let's try that and see if it works. Now, if you ever start something and it's not working, just erase it and try something else. Okay, that is the cool thing about math, is it's supposed to be looking for patterns and looking for different solutions. Don't be afraid to try something and have it not work. Lots of times when you make those mistakes, that's when you actually end up learning more. Okay, so I rewrote it. F of x, I'm saying, well, that's e to the x. But I don't just have e to the x. I have e to the cosine of 2x. Okay, so that's my g of x. The derivative, now this is a chain rule because I have the cosine of 2x. Okay, so what happens here is I'm going to have to first figure out what is the derivative of the cosine. It's a negative sine of 2x, but because this is more than just an x, you take the derivative of 2x and you get a 2. So this is negative 2 times the sine of 2x. Okay, so again, this was the chain rule because this is more than an x. A derivative of a cosine is a negative sine. You leave the 2x how it is. Because this is more than just an x, you find the derivative of 2x, which is 2, and you have to multiply that. The negative times the 2 is how I got a negative 2 sine of 2x. I have a sine of 2x, but what I'm missing is the negative 2. So in order to cancel that negative 2, that means there had to have been a negative 1/2 out front, because a negative times a negative would have made that positive. 1/2 of 2 would have made it just a 1 sine of 2x, which is what we have. So I do have a negative 1/2 out front this time. Now the antiderivative of e to the x is e to the x plus c. Antiderivative e, but instead of x, you fill in your original g of x. So here is my final answer. Negative 1/2 e to the power of cosine of 2x plus c, and you are done. And again, I think that was kind of a trickier one just because we had the e and then we ended up having to put the negative 1/2 up front. So a little bit tricky. Here is our second one that I consider an actual challenge problem. We're looking at a cotangent. I do not have a derivative or an antiderivative or a derivative. I don't have either of them for a cotangent. So what I need to do is rewrite it in a format that includes things that I know. Cotangent is the reciprocal of the tangent. So if the tangent is sine over the cosine, like we looked at in number 2, the cotangent would be the cosine over the sine. So step 1, you'll have to rewrite it using sines and cosines because we know the antiderivatives of sines and cosines. So now I can move further in the problem. Just like in number 2, I wanted to work through a couple like this. This is a fraction. I can go 1 over x. G of x, well, instead of just an x on the bottom is a sine of x. The derivative of g of x, our g of x is sine of x. The derivative of a sine of x is a cosine of x. I have a cosine of x, so that matches. So I do not need to add a value out front. I don't need a negative, any other numbers, because the cosine of x already matches. So that's perfect. The antiderivative of f of x is 1 over x. The antiderivative of 1 over x is the natural log of x. Because I'm taking an antiderivative, I have to remember to add plus c. So my formula, antiderivative natural log of, instead of x, it's g of x. So the sine of x plus c. That's all that one would be. But again, I do kind of consider that one more of a challenge question because you have to know trig ratios in order to rewrite the original problem into a format where you can use integration by substitution. Last question. Again, thinking of that outside piece, I see that there's a 3 on the bottom. So step 1, I rewrote this because it just kind of made me feel better to look at it in this format. I said, all right, these two things mean the same thing. Now, the reason I like this more is because I can see, okay, what is the main piece? The main piece is to have that exponent of -3. So that gives me my f of x. So f of x is x to the -3rd power. G of x, it's that composition. What did you fill in for x? Well, we filled in 2 plus the sine of x. Now we have to find the derivative of g of x. The derivative of 2 is 0. The derivative of a sine is a cosine. I do have the cosine of x. That already matches, so I do not have to add a value outside. Find the antiderivative, x to the power of -3. If I add 1, that becomes a -2. If you divide by a -2, that's the same as multiplying by a -1/2. X to the negative power of 2. It is an antiderivative, so it's plus c. So again, I took my -3, I added 1. That's how I got -2. If you divide by -2, that's the same as multiplying by -1/2. Now I'm going to take the antiderivative, -1/2, where x is, fill in your original g of x, 2 plus the sine of x. You still have your -2. It's still plus c. This is fine if you got it to here. Okay, I don't like having negative exponents in my final answer. So what I did for my final answer is I have my -1 over 2 because it's negative 1 over 2. That's how I get the 2 on the bottom. Then it's the group 2 plus sine of x to the power of 2 on the bottom because it's negative. So I wrote it like this. If you kept it like this, they are equivalent solutions. And you guys, we have finished 9.1. So this week we've really looked at a process called integration by substitution. Yesterday, it was so nice seeing some of you guys on that Zoom call. I hope it helped out. And yesterday was just a quick quiz on the first part. Today we added in the trig functions. I picked out 5 questions that I would like you to try just to make sure that you're really understanding this. Tomorrow is a worksheet workday. So you are just going to continue working with integration by substitution. The main thing when you're doing the worksheet, when I grade them, every problem is worth 5 points. So what you need to make sure you do is tell me what is f of x, because that's a point. What is g of x? That's your second point. Find the derivative of g of x. Find the antiderivative and then the final answer. So please, as you're looking at your worksheet tomorrow, make sure that you do give me all 5 steps. I hope you guys are having a great week so far, and I'll talk to you soon. Bye.